Hi everyone. In today's lesson, we're going to talk about coterminal and reference angles. Angles are said to be coterminal if their angles in standard position have the same terminal side. And the way that you calculate coterminal angles is that you can add or subtract any multiple of 360. So let's show you what I mean by that. So do you see here how this positive angle here in red is 120 degrees, and this negative angle here in green is negative 240. Both angles have the same terminal side, right? The terminal side is where the angle ends. So how do we get that? Well, you could take 120 and subtract 360. Take a minute, pause the video, put that in your calculator, and see what you get. So if you subtract 360, you should get 240. Now, what you also could do is you could take the negative 240 and add 360. Go ahead, pause the video, see what you get there. You should get here 120. So what you just proved by subtracting 360 or adding 360 is that negative 240 is coterminal with 120, and that negative 240 is also coterminal with 120. So same thing, you can either add or subtract, and you get the other angle. Now, we could add or subtract more than once if we wanted. So let's just say we took the 120 and subtracted 360 twice. Let's take a minute, pause the video, type that into your calculator, and see what you get. All right, so you should get negative 600. So let's graph that on here just to show you that it still ends up in the same spot. So we've got 0, negative 90, negative 180, negative 270, negative 360. If we keep going, this would be negative 450, then negative 540, and then negative 630. So let's see, if I were to graph that, I'm going to choose to use a different color. Let me choose yellow. So my initial side is always in the same spot, and negative 600, well, I'd have to go around one full time, and 600 would probably be somewhere exactly right here. Why? This is negative 540 and this is negative 630. So look, see how no matter what I do, I'm still winding up at the same angle. So what coterminal means is you could add or subtract 360, any multiple, and still wind up with another coterminal. So let's look at how they'll ask questions. So it says, find a positive and negative coterminal angle for each. All right, so let's start with 125. I want a positive coterminal angle. So I could just simply take 125 and add 360. If I do that, I get 485. So this is one possible coterminal angle, but I also could take 125 and add 360 twice if I wanted to. And if you do that, you get 845. So both of these, 485 and 845, those are both positive coterminal angles that you could have here. Now, a negative coterminal angle, I would do 125 minus 360. That's the only way you're going to get it to be negative, right, if you subtract a bigger number. So that would give me negative 235. Now, another possibility, you could take 125 and subtract 360 three times if you wanted to. And that would still be a negative coterminal angle. So pause the video and see what you get. All right, so I got negative 955. So these are all examples, negative 235 and negative 955. So technically, there's an infinite number of coterminal angles because couldn't we just keep subtracting 360 here or adding 360 here? They just want one. Find a positive coterminal angle, find a negative coterminal angle. Choice is yours where you want to stop. So take a couple minutes and try questions 2 and 3 here. Call those for homework, and then let's move on to the second page. Okay, so a new definition, a reference angle. A reference angle is the acute angle formed by the terminal side of an angle and the x-axis. So let's do an example of an angle in quadrant 1. So I'm just going to pick an angle to be 40 degrees. So we know we need an initial side, and we know that since 90 degrees is here, 40 is probably going to be somewhere there. That would be my terminal side, and this would be 40 degrees. So if I wanted to find the reference angle, it's the acute angle formed by the terminal side of the angle, which is here, and the x-axis, which is here. Terminal side and the x-axis. Well, that angle is right there, and it's 40. So what this tells me is that angles in quadrant 1 are their own reference angle. And that would be true if I had, say, 35 degrees or 60 degrees. It would still be the terminal side of the angle, and the x-axis would still be right in this spot. So let's do an example maybe in quadrant 2. So I'm going to pick maybe 120 degrees. So if I want to graph that, I need my initial side, which we know is here, right? That's my 0. We know this is 90 and this is 180. So 120 is probably going to be somewhere here. And from here to here is 120. So let's see where the reference angle is going to be. It's the terminal side of the angle and the x-axis. Well, this is the terminal side of the angle, and this is the x-axis. So it would be this angle in here, I'll use green, would be my reference angle. And the way that you can calculate that is, well, if I'm going from here to here is 120, think about it. How many more angle degrees do you need to finish the angle to get to 180? So 120 plus what gives me 180 is 60. So here's my reference angle, right? And the way that you'll always be able to calculate that is just do 180 minus the angle. We'll call theta the angle. So in this case, it was 120 and 180. So 180 minus the angle gives me 60. So this is how you find a reference angle in quadrant 2. Okay, how about a reference angle in quadrant 3? So I'll pick another angle. Let's just say I pick 220. So we know this is 180. We know this is 270. So my angle will always start here. That's my initial side. And 220 probably going to be somewhere here. We've got this angle from here to here. So since this angle is 220, the easiest way to find the reference angle is first, let's locate it. Terminal side of the angle and the x-axis. So the reference angle is going to be this little piece in here. And the way that we can find this is if we take the angle, we'll call it theta, and subtract 180. And let's show you why. So the easiest way to explain it is that from here to here is 220. And if I get rid of this 180, right, this half moon, I would just be left with this piece. And that's how you find it. So in this case, it would be the angle 220 minus the 180, and that would give me a reference angle of 40 degrees. And that would be in here. All right, last but not least would be a quadrant 4 angle. So let's pick one, maybe 300. So here's my initial side, never going to change. Here is 270, and here is your 360. So I'm thinking 300 will probably be somewhere here. So if I go around, right, here's my 300. And the reference angle, let's first find it, is between the terminal side of the angle and the x-axis. So that would be in here. So you could ask yourself, this one's kind of easy to see, 300 plus what gives me 360, right? Fills the circle. So you would say 60 degrees. How you can solve that is by taking 360 and subtracting the angle. So in this case, we start with 360 and subtract the angle, which is 300, and that will give me a reference angle of 60 degrees. So these are the 4 rules to find reference angles depending on what quadrant you're in. So let's look at a couple of examples. So there's something special to note though. It says if the angle is greater or less than 360. Really what it should say, if the angle is greater than 360 or less than negative 360, you must use coterminal angles first, then you can find the reference angle. So we'll talk about that when we get to it. So let's start with example number 1. Angle is 120. We know that's an angle in quadrant 2. 330 is an angle in quadrant 4. So these two are normal angles. They're normal angles. Why? Because they're in between 0 and 360. So is there a coterminal angle needed? No. Same thing here. This angle is between 0 and 360, so there is no need for a coterminal angle. So my reference angle here for quadrant 2 is simply 180 minus 120, which is 60. And then for the quadrant 4 one, it's 360 minus the angle, which is 30. So these two are simply following the rules up here. Figure out what quadrant is here and just follow the rule that you see. But a problem like negative 495 and 600 is that these angles are not in between 0 and 360. So a coterminal angle for these are absolutely necessary. So what our goal is to take the 495, the negative 495, and try to add 360 first. And if we get an angle that's between 0 and 360, then we're good. We might have to add more than once, but let's just see. So I'm going to take negative 495 and add 360. That gives me negative 135. That's not good enough. I need an angle between 0 and 360. So I'm going to add 360 one more time, and that's going to give me 225. So now this angle is much better to work with. So that's a quadrant 3 angle. And the rule to find a reference angle in quadrant 3 is you take the angle and subtract 180. So 225 minus 180 will give me a reference angle of 45. So you cannot use these reference angle rules up here until you get your angle to be in between 0 and 360. So same thing with 600. It's too big. So we're going to use coterminal. Let's subtract 360 and see what we get. Why am I subtracting? Because I need to get down smaller. So if you do that, you get 240. And that's actually perfect, right? 240 is an angle in quadrant 3 again. So the way that you find the reference angle is you take the angle and subtract 180. And that should give me 60. That's my reference angle. All right, I know that was a lot. So now's a good time to jot down any questions if you're confused, and we'll touch base tomorrow in class. All right, have a good night.